Good morning, everyone. Welcome to my presentation. My name is Ferry Jaya Permana. I am a lecturer at Parahyangan Katolik University, Bandung. I would like to present my work with the title Application of Linear Hazard Transform to the Indonesian Mortality Table. This is a joint work with my colleague Iwan Sugiarto and my student Johannes Johan. My paper is submitted to the Science and Technology Research Symposium, or SiRes 2020, which is organized by Universitas Islam Bandung. Let's start with the presentation. What is motivation of our work? As we know, mortality table is one of important component for pricing insurance product. For example, to calculate life insurance premiums. In Indonesia, insurance companies use Indonesia Mortality Table, which are called TMI. However, TMI is not released every year due to some limitation, such as cost and time. When the new mortality table has not been released, we will use survival probabilities from the last released mortality table. Hence, pricing insurance products can be inaccurate, maybe too low or too high, and that is the risk for insurance company. There are several techniques for reducing risk by assuming survival probabilities or force of mortalities change from year to year. We will discuss linear and proportional hazard transforms proposed by Wang. Linear hazard transform assumes force of mortality changes following linear function. Let's take two points of time, today and future time, which are called target year. Today's force of mortality is denoted as nu R, and in the target year denoted as nu B. Relationship between today's force of mortality and in the target year is given in equation 1. Recall relationship between force of mortality and survival probability, which is given in equation 2. This implies relationship between today's force of mortality and in the target year, as given by equation 3. This leads to parameter estimation or Q-fitting problems. Wang proposed to approach KPX fitting and PX plus K fitting. If we apply linear hazard transform using KPX fitting, then survival probabilities in the target year can be approximated by equation 4. Sum of square error of this curve fitting is given by equation 5. Now our task is to estimate parameter alpha and beta. Good approximation can be obtained by minimizing sum of square error. This means the first derivative with respect to parameter alpha and beta equal to 0. Then parameter of transform can be obtained by equation 6. If we apply linear hazard transform using Px plus K fitting, then survival probabilities in the target year can be approximated by equation 7. Sum of square error of this good fitting is given by equation 8. To estimate parameters alpha and beta, we determine first derivative of sum of square error with respect to parameter alpha and beta, and those first derivative have to equal to 0. Parameter of transform can be obtained by equation 9. Proportional hazard transform is a special case of linear hazard transform, where beta equal to 0. This transform assumes force of mortality changes proportionally. In case of performance of linear hazard transform and proportional hazard transform are comparable, then we shall choose to apply linear hazard transform because working in one parameter is simpler than two parameters. And here, proportional hazard transform might be preferable than linear hazard transform. Relationship between today's force of mortality and in the target year is given in equation 10. Similar with linear hazard transform, we will apply to approach to estimate parameter when we use proportional hazard transform, KPX fitting and PXK fitting. In this slide, we can see that. In this slide, we can see how to approximate force of mortality in the target year from today's force of mortality if we apply proportional hazard transform using Px plus K fitting, sum of square error, and how to get estimation of parameter alpha. This slide presents approximation of force of mortality in the target year, sum of square error, and parameter estimation when we apply proportional hazard transform using Px plus K fitting. We apply linear hazard transform and proportional hazard transform to the Indonesian mortality table for male. Term E2 is released in 1999 and term E3 is released in 2011. So we choose 1999 as today and 2011 as the target year. We also choose x equal to 30 and n equal to 20. Standard error is defined as square root of some square error divided n. Let's compare standard error of linear hazard transform and proportional hazard transform. The result is provided in table 1. We can see that standard error belongs to linear hazard transform. It's much more smaller than standard error of proportional hazard transform. So we can conclude that linear hazard transform perform better than proportional hazard transform. But that's not fair if we look at standard error to compare performance of KPX fitting and PX plus K fitting, since the sum of square error is based on different terms. Here, we try to compare performance of KPX fitting and PX plus K fitting when we apply linear hazard transform. Remember, KPX can be written as the product of PX plus G. So, from PX plus K star obtained from PX plus K fitting, then we can obtain KPX star. And vice versa, if we have KPX star obtained from KPX fitting, then we can also obtain PX plus K star. So now we have the same differences. KPX star from KPX fitting and from PX plus K fitting, PX plus K star from KPX fitting and from PX plus K fitting. Next, we compare absolute error to measure discrepancy between the approximation value and exact value. Approximation values are calculated by using survival probabilities obtained from linear hazard transform. Exact values are calculated by using survival probabilities from TME2 shows that standard error obtained from KPX fitting is much more smaller than obtained from PX plus K fitting. It means that KPX fitting performs better than PX plus K fitting when we use linear hazard transform. Now, we want to investigate performance of linear hazard transform using KPX fitting and PXK fitting by comparing approximation value and exact values of net single premium at present value of life annuities. Table 3 shows that mean and standard deviation of standard error obtained from KPX fitting is much more smaller than those obtained from PX plus K fitting for both differences, KPX values and PX plus K values. So it shows that KPX fitting performs better than PX plus K fitting. Conclusions. Application to TME2 and TME3 shows that linear hazard transforms perform better than proportional hazard transform, and KPX fitting perform better than PX plus K fitting. So what we want to do for the next research, after we apply linear hazard transform using KPX fitting, then we want to extrapolate survival probabilities to predict or to approximate the future survival probabilities. That's all my presentation. Thank you.